The whole universe was in a hard, dense state, and I'm not going to do it again, I promise. Okay, so last lesson we did the Big Bang along with redshift a little bit. So remembering that the Big Bang is everything starts from one point of single density and then is expanding outwards, and that is evidence for redshift and how, as galaxies are moving away from us, the colour of light being emitted is shifted to the red end of the spectrum. But what we're going to look at is before and after the Big Bang and theories as to what is going to happen in a bit more depth. Okay, so why did scientists come up with the idea of Big Bang? Because most of them subscribe to the steady state theory that sort of matter density has been the same for a really long time. Well, it's because we started seeing these galaxies moving away from us. We started being able to observe them and actually observing cosmic microwave background radiation, which means it kind of gave us an idea that everything seems to have come from one point in the universe, and this radiation has come from an explosion that had happened. Everyone can reach grade 8 on this lesson. It's not overly complicated, it's just using the right words. So you need to state that the current accepted model for the early universe is the Big Bang. If you can't do that, well, I think you can all do that. I was going to say give up, but never give up. Discuss why scientists were reluctant. Well, there's this little thing called evidence, and the fact that it happened 14 billion years ago, kind of difficult. So there were other ideas, and also religion and things like that. Outline recent discoveries that have led to the changes. Well, this is about talking about the cosmic radiation and talking about redshift and how it develops. But this is also synthesis. You might be able to look at one and see how that would change the theory. And then you need to be able to describe redshift as evidence. Well, we just did that on the starter. Tick. Describe evidence that supports the Big Bang theory, that and cosmic microwave background radiation, and then explain in a bit more detail, so using the correct scientific vocabulary and applying it to examples. Easy, let's go. So the Big Bang theory stated that the universe is expanding from a very small dense region and time and matter was created at the Big Bang. So just so you're clear, from that one point it went in all directions, but this is just illustrative. 15,000 million years, and we've got man and DNA and stuff like that. Here is where we have sort of more complex atoms being formed, and again even more complex atoms being formed. We've got simple fusion happening here and simple particles and fusion happening here. So from that time scale moving outwards. Not the only theory. Like I said, Einstein kind of subscribed to the steady state theory, and that the idea that the theory is that the universe is being pushed apart by matter that's created in white holes. So this kind of matter is being created, and so we've got an expanding universe that is the similar amount of density, so like a similar amount of mass. For many years this was accepted, so why did they change their minds? Well, because it means that we would still be the same distance away from galaxies, whereas these two are getting further and further apart, and we've measured differences with evidence that we are getting further and further apart. But in this one, in this model, it means that we're not getting further apart, so we have evidence using redshift. Both theories explain why distant galaxies are moving away from us, but scientists also put their thinking caps on and thought about the fact that the Big Bang would have produced high energy electromagnetic radiation. Now think back to when we did waves. Now when we did the EM waves, we had low energy waves, so low frequency, long wavelength, and then we put them in order until we had these really high frequency ones. So we had the gamma ones, that's an X, the X ones, UV, visible light, infrared, microwave, and radio waves. Okay. And so they theorized that if the Big Bang happened, there'd be a huge amount of high energy radiation, so the X and the gamma rays. But over time, since they've been spreading out, the waves have been stretched, which means that they're much lower energy, lower frequency, which means they're forming microwaves. Now, we detect this all over the galaxy. Okay, so when you put your TV on and you tune it, now, this probably hasn't happened because you're all a lot younger than I am, but you get this kind of like that happens. That's cosmic background radiation. And the same if you ever have had to tune a radio, you get you can detect that, and it's coming from space, and it's microwaves. And they discovered that in the 65. They discovered that there were microwaves moving in the galaxy from every direction. Oh, no, that says ever direction. Every direction. Cosmic microwave radiation can only be explained by the Big Bang. It can't have come from anywhere else because it's everywhere. If it came from a star, it would be quite zonal. Don't know what I'm just scribbling on this now. It would be quite zonal. Here are some questions. Pause it, see if you can answer the questions. Seriously, pause it, see if you can answer the questions. I know you know I'm going to go through them, but pause it. Use your brain. Okay, let's go. So, describe the theory of the universe, Big Bang theory of the universe. So, all matter started from a single dense point and exploded outwards 14 billion years ago with high energy electromagnetic radiation. Explain why many astronomers did not support the Big Bang theory when it was first proposed. This is worth 2 marks. So, you'll get 1 for saying observable evidence. Finding no observable evidence, because obviously nobody was there. Okay, and you can also then move into the fact that we couldn't see that the galaxies were moving far apart from one another, etc. Explain the significance of cosmic microwave radiation. Okay, so this allowed us to see an EM wave which comes from every direction, which could have been the result of stretching high energy wave radiation. Put these into the correct sequence. The distant galaxies were created. Cosmic microwave radiation was first detected. The Big Bang, that's going to be number 1. And the expansion started. That's number 2. Distant galaxies were created. 3. Cosmic radiation was detected. 4. Okay, so we already spoke last time about the ways that it could end. 2 ways it could possibly end that we think. It could expand forever and give the heat death, or big yawn, or big freeze, otherwise known as. I love this top. It says, I'm not lazy. I'm prolonging the probable heat death of the universe by conserving energy. I absolutely love it. It's kind of one of those things that there was a word I thought of earlier that would describe it, but it's the kind of thing that I would have wanted to be like, actually, I'm prolonging the heat death of the universe. Okay, and then there's also the idea of the big crunch, that it will expand, and then boom, it will contract back in on itself, form a whole load of black holes, which drags everything into a single point, and then it's going to boom out again. Big crunch. And depending on what happens, depends on the density of the universe. Watch this brilliant graphic. Ooh. So the stars and galaxies only account for a small percentage of mass in the universe. And we know this because galaxies would spin faster if the stars were the only thing in them. So basically, there's this stuff called dark matter. And what they're saying is, based on the mass that we can see and measure in the universe, galaxies should be spinning way quicker, but they're not. So there must be mass from something else. And this missing mass is known as dark matter. We can't see it all. It's missing mass, but it's got to be the thing that's slowing down the galaxies moving. But it kind of, makes mass work. Right, so big yawn, big crunch on a graph. So here's the Big Bang. So either the universe carries on like this, blah, 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 then it starts to cool down and run out of fuel. Okay? And then everything's dead. Or it's going to collapse back in on itself, form loads of black holes, and then once it's formed all these black holes, it's then going to back out again, and then big crunch. So what's that got to do with density? Well, if the density is below a certain amount, we're going to go for yawn. If the density, so hilarious. If the density is above a certain point, it's going to be crunch time. The trouble is based on the speeds that all of the galaxies in the universe that are moving, it's difficult to quantify what the density is then. So if we look at the galaxy, it's so more galaxies that are accelerating away from us. For them to be accelerating, there has to be a force pushing on them, and the only force coming back is gravity. This means that something else must be causing it, not just dark matter, to be accelerated. So there's got to be something that's moving it quicker to overcome this dark matter as well, because they're accelerating away from us. So they've come up with this idea of the fact that there is a dark energy pushing galaxies away with only a small amount of gravity, well, it's quite a large amount of gravity. And 4.9% of the universe is ordinary matter. I don't think anything ordinary matter. Just matter would have been fine, because you've got dark matter we can't see, and you've got this dark energy force pushing galaxies away. Just regular matter would have been fine. Okay, watch this video. I realise that not all of you will necessarily watch this video, but it will help you answer the multiple choice questions. Obviously, I'm going to go through the answers, but I would suggest that you watch it, because it's really good. Okay, what is the shape of the universe? I always thought it was the shape of a sombrero, because I watched it on QI once, but it is in fact flat. There might be a bump in the middle, I suppose. Dark matter is dark because it does not react strongly with light. Dark energies cause the expansion of the universe to accelerate, go faster. So that's what we're talking about. There must be something forcing it forwards. And if you paid attention to the graph before, the universe is made of dark energy. It's about 60% dark energy, which is a huge proportion that we don't know about the universe, but it is pretty vast. I believe, one more question, we think that we have about the right density for the big freeze. That is more likely, but we can't fully measure the density of the universe because we don't know its volume or its full mass. So it's tricky. And it's not like we can wait and see, because there'll be a lot happens before that happens. Anyway, hope you're right. Take care. Have a good weekend.